In this video, we're going to use Excel to examine the relationship between two continuous variables. The first thing we're going to look at is the covariance. Then we're going to look at the correlation coefficient. So I have three variables here. We're going to use this data later, so we'll only use the first two variables. So the variables are the consumption of energy in kilowatt hours, the outside temperature in degrees Fahrenheit, and the percent of the roof that's in the shade. So let's begin by looking at the relationship between energy consumption and temperature. We'll start with covariance. Basically, the covariance will tell us the deviation from the mean for each variable's value. So it's a deviation of the first value, 126, from the mean energy consumption, multiplied by the deviation of 30 here, minus the mean of the temperatures. Then we'll add to that deviation of 132 minus from the consumption mean by the deviation of 25 from its mean. Here going so on and so forth, adding up all of these together. Now, the covariance is simply the average of those products of the deviation from the means. To get the covariance in Excel, we're going to click on functions and use the statistical category. So functions, go to the statistical category, and we will select the sample covariance. The covariance is with the S for sample. So we'll highlight the first variable is A2 to A33. And then for the second one, we will go and select temperature. So B2 to B33. And that gives us the covariance, which is equal to 508.69. Now, the covariance can be hard to interpret sometimes because the variables can have widely different scales. So we don't know, just looking at this, whether 508 is large, whether it's small. It depends on the actual values of all the variables. But it is valuable. It can tell us the relationship or the direction of the relationship. But typically, we report the correlation coefficient. It's more standardized. It's simpler to work with and compare between models. So let's compute the correlation here. There are two ways to do that in Excel. I'll go ahead and demonstrate both. So again, we're going to use function. Stay in the statistical category. And the function correl is correlation. Scroll down to the C's, correl right there. So we'll just simply highlight the two variables that we want to get the correlation for. But just like last time, consumption will be in the first one, and then we'll put temperature in the second one. But for correlation, it doesn't matter which order you use. And then we'll just simply click OK. So the correlation coefficient, which goes between -1 and 1, is -0.86769. So this is a strong relationship, and it's also a negative relationship. Now, a different way to get the correlation coefficient is to use the data analysis tab. So go here to data, over to data analysis, and to click on correlation. So it's going to ask us about labels. Because we have labels there, we can put labels in the first row. And then for the input range, we just highlight both of the rows. Or both of the columns, excuse me. Let's leave the output range in here, and it's grouped in columns. It's already selected there, so we don't have to worry about that. The output range, I will select right there just to put this in our thing. So here we have the two variables, consumption and temperature. Here, consumption with itself is 1. That's your perfect linear relationships. And we get this when there are, when we accidentally take the correlation of a variable with itself. Same thing for temperature and temperature. But here we have the correlation for consumption and temperature. And we see we get the same answer here, maybe some more decimal points, but it's the same number. Now, if we did this again, so go to data, data analysis, if we select correlation, if we select all three, we can then get the correlation between each of those three different variables. And I'll put this down here so it's not overwriting the same thing. So here we see consumption, temperature, and percent of the roof that's in the shade. So we can see here not just the relationship between consumption and temperature, now also including percent of the roof in shade. And here we see much weaker relationships rather than negative 0.86, positive 0.14, positive 0.015. So these are very, very weak relationships. Now, the only problem with doing this, like we just did it in Excel, is that we don't know what the statistical significance is. So we get this correlation coefficient, but we don't know the p-value. Sure, this is large and these are small, but how trustworthy are these estimates? How much are they due to random chance? Can we really reject the null hypothesis? Um, to do that, we're going to need the p-value. Now, to do that, we're going to have to use the regression, and that's something we're going to talk about in a future video.